Hi families, students are now learning how to compare fractions that have unlike denominators and numerators. So the denominators are different and the numerators are different. Students have learned that they have to have common denominators in order to compare two fractions. So the denominator is the number at the bottom, and the numerator is at the top. So I'm going to take you step by step of how students are required to do this right now. This is a method that they will learn with comparing fractions and multiplying fractions in 5th grade and in middle school. So I know it's long, but the students, the more they practice now, the better they will be and the more successful they will be. So students are taught to start when there's something like this where they just have to compare which is true and there's just answer choices. They are required to solve every single answer choice to see. So I'm going to solve each one of these and I'm going to show you how they are supposed to. So we start, I'm going to write it over here with A. It's saying that 1/3 is greater than 7/2. Now I don't have the same denominator, so I'm going to start by circling my denominator. Next, I'm going to write my denominators, and I'm going to write a list next to them, hence the colons. I'm going to write multiples of each digit, which is just skip counting, in order to find the smallest number that they both have in common. So for example, I'm going to skip count by 2. 2, 4, 6, 8, 10. I just stopped at 10 because I just did a couple of numbers, and now I'm going to see if any of these numbers are in the multiples of 3. 3, 6, 9, 12, 15. Now I see on my list that I have a 6 here, and I also have a 6 here. So I'm going to circle those two numbers. This 6 is now my denominator. I need to turn both of these fractions into something with a denominator of 6 so that I can actually compare. This is the part that students sometimes get tripped up about. I'm going to now take my fraction, 1/3, and I'm going to put a fraction line with a 6 here. I'm going to then draw an arrow from my old denominator to my new denominator. I'm going to ask myself, 3 times what gives me 6? In this case, I know 3 times 2. Students were taught if they didn't know right off the bat, they can go back up to their chart. 3 times what? 1, 2. I'm going to write a 2 here. Students were taught whatever they do in the denominator, they have to do in the numerator. So now I'm going to, just like I drew an arrow here, I'm going to draw an arrow from my old numerator to my new numerator. And I multiply by 2 here. Again, I have to do the exact thing to my numerator. 1 times 2 is 2. So now 2 6 is the same thing as 1/3 because I did the same thing to my denominator and my numerator. So this is an equivalent fraction. It is the same. Now that I switched my 1/3, I now have to go and do my 7/2. I'm going to write 7/2 here. I'm going to write my fraction bar with my new denominator, my 6 again. I'm going to draw an arrow from my old denominator to my new denominator. And again, ask myself, 2 times what gives me 6? I know that 2 times 3 equals 6. Whatever I do to the denominator, I also have to do to the numerator. So I'm going to draw an arrow from my old numerator to my new numerator. I'm going to go ahead and write my times 3 again. These are the exact same. I know that 7 times 3 is 21. So my new fraction, or my equivalent fraction with 7/2 is 21/6. Now that I have two fractions that have the same denominator, I can just look at the numerators to figure out my comparison. In this case, I know 21 is greater than 2, so my symbol is a less than sign that has the 2 points facing towards the larger fraction. Now I go back to answer choice A. My symbols are not the same, so answer choice A is not true. I'm next going to go to B. I have 6/6 and 1/3. I'm going to now see if 6/6 is actually less than 1/3. Now I understand that students know that 6/6 equals 1 and 1 is greater than 1/3, but I'm trying to get them to learn this system so that they are prepared for 5th grade. So I'm going to circle my denominators again, and I'm going to make my list. I have 6, I have 3. I'm going to skip count to find the lowest common multiple. 3, 6, 9. For my 6, I have 6, 12, 18. So I know that 6 is the smallest number that they both have in common. I'm now going to go ahead and take my first fraction of 6/6. In this case, the new denominator is 6, but in this fraction, I already have a 6, so I do not have to change that one. The only fraction I'm going to have to change is my 1/3. I know that 1/3 turns into something with a 6 as a denominator because it's my common denominator again. I'm going to draw an arrow from my old denominator to my new denominator. I'm going to ask myself, 3 times what equals 6? I know that 3 times 2 equals 6. Whatever I do to the denominator, I have to do to the numerator. So I'm going to draw an arrow from my old numerator to my new numerator. I'm going to write my times 2 here. And I know that 1 times 2 is 2. So 2/6 is an equivalent fraction to 1/3. Now I'm going to compare. I know that 6 is greater than 2, so my symbol should be in this direction with the 2 points facing the greater number. That is not what answer choice B has, so I know B is not correct. I'm now going to go to C. I have 4/5 greater than 1/6. Again, I do not have common denominators, so I have to solve. I'm going to circle my numbers, my denominators, and go ahead and do my list. Students sometimes have challenges with this because up here, A and B will have smaller numbers. But down here, it's going to take us a little bit longer to find our common number. I'm going to start by counting by 5s. 5, 10, 15, 20, 25. I'm going to go to my 6s. 6, 12, 18, 24. I still don't have a common multiple. In class, students got stuck on this step. Most of them only wrote their list until this point. But I told them if they just keep going, they will find a common denominator, a common multiple. So in this case, it's 30, which is a larger number. So I'm going to take my 4/5, and I'm going to find the equivalent fraction for 30. I'm drawing an arrow from my old denominator to my new denominator and ask myself, 5 times what equals 30? In this case, I know it's 6. Again, I can check myself by going to my list of 5 and counting how many numbers I have. 1, 2, 3, 4, 5, 6. Whatever I do to my denominator, I have to do to my numerator. So I'm going to draw an arrow from my old numerator to my new numerator. I'm going to write the same number here that I wrote over here because I have to do the same. 6 times 4 is 24. I'm going to do the same thing now with 1/6. I have my 30. I draw an arrow from the old denominator to the new denominator. I ask myself, 6 times what equals 30? I know the answer is 5. Whatever I do to the denominator, I have to do to the numerator. So I'm going to take an arrow from my old numerator to my new numerator. I do the same exact thing, and I know 1 times 5 is 5. So now I can compare. I know that 24 is larger than 5, and again, I'm looking only at the numerators now because my denominators are the same. So I have the greater than sign with my 2 points facing to the larger number. Now I'm going to look at my answer choice. This is the same as this, so I have found my correct answer. Students are required to still solve D, but for the sake of how long this video is, I'm going to stop at C. If there's any more questions, feel free to reach out. Thank you.